Good morning, good afternoon, everyone. Welcome to another exciting Exploring by the Seat of Your Pants broadcast. And I've got to say, as someone who's hosted over 1,500 of these, that new intro, watching kids like headbang in the background and have epic dance parties in classes, you guys rock. So thank you all very much for that. If you are joining us for the first time, and quite a few of you are today, we are all about bringing conservation, adventure, and science into classrooms around the world. Literally a few hours ago today, I was hanging out live in Lahore, Pakistan with Uzma Khan talking about saving endangered river dolphins, and now we get to talk Mars rovers. And I mean, that is the joy of Exploring by the Seat of Your Pants, is you get to hang out with the coolest scientists and explorers on planet Earth. So everything's on our YouTube channel. You can check out like 3,500 past programs there, lots to explore and discover. Now, before I dive in with our speaker of the day, I want to highlight, we've got a Kahoot today. So between our talk and our Q&A, you can join us with a little 4-question quiz right there. So pull that up in a separate tab. We look forward to doing that in about 25 minutes or so. Now, I'm really excited today for 2 reasons. Number one, we're bringing back one of my favorite people from last year, Dr. Ashwin Vasavada. He is a Mars project scientist, so he gets to work on designing and understanding amazing robots that go to other planets to explore other worlds. If there's a cooler job than that, I don't know what it is. He gets to work at NASA's Jet Propulsion Laboratory, which is one of the most storied and amazing places on planet Earth. Truly, we get to feature a lot of people from there, but we are so lucky to do that because it's like a whole bunch of people that have the coolest job in the world. And 2 is that we're diving back in with Mars. October is our space month. We've got a whole bevy of amazing engineers, scientists, astronauts, hopefully to come this month. So please do check out our full listing on our website. And it's so exciting to dive in first with Ashwin. So without further ado, I'm going to stop talking. Ashwin, welcome back to the program, man. And thank you for joining us again.
All right. No, it's fantastic to be here. Let's go to Mars.
Let's go to Mars. I mean, you've got it literally behind you. I was just saying to him before we got started, I got a moon globe over here. Ashwin's got, where is it? Somewhere. Got a Mars globe, which is amazing and so much fun.
Yep. This is an old one too. That Mars globe. Oh, where is it? There it is. Yeah. It was made from people looking through telescopes at Mars in like the 1950s. So we know a lot more about Mars today than back then.
We do. And I know we're covering that in your talk. So I'm going to zip it and disappear. If you want to bring that up and take us on a journey to another planet, I think we're all pretty chomping at the bit here.
Let's do it.
Amazing. A big welcome into our YouTube classes as well. I know combined we have 800 kids today. So thank you all so much for being here. And with that, it looks like we are good to go. Take us away.
All right. All right, here we are. So thanks everybody for joining us today. I'm really excited to tell you about everything this robot has been doing for the past 12 years exploring Mars. So what you're looking at here is a real picture of Mars. This was taken a few years ago as Curiosity, which is the name of that robot, was exploring Mars and doing its thing. You can see that it's a big robot. We'll talk about that. It's been up there for 12 years. I've been working on it for almost 20 years because we started designing it in 2004, actually even 2003. And then it launched from Florida in 2011, got to Mars in 2012, and we've been driving around a place called Gale Crater and Mount Sharp within Gale Crater for about 12 years. You can see on this rock in front of the rover, there's a hole in it. And that's one of the things that makes this rover special is that it's so big, partly because it carries a 7-foot robotic arm with a drill at the end of it. And the drill creates these holes in the rocks, and we take the material from inside the rock and we analyze it in laboratories that are built into the front end of the rover. So this robot isn't just driving around, it's doing science on Mars by bringing laboratories from Earth to Mars, drilling into rocks, getting the powder from those rocks and dropping it into some laboratories, 2 different laboratories, running experiments and sending the results back to Earth electronically. And so you can't see the arm on this, and that's because the rover was taking a selfie of itself using its arm. We're the first mission to try this on Mars, and we realized, kind of as we were building the rover, that the camera that we had built for the rover to take close-up pictures of rocks on the ground, actually, you could turn that camera back at the rover and take a picture just like you do with your cell phone. So that's how this was made. One interesting kind of fun fact is that the images we take with our arm-mounted camera are actually pretty small. So it actually takes 55 different pictures. We have to take 55 selfies and then stitch them together to make this beautiful picture that you see here. But we'll talk a lot more about what the rover's doing. My name is Ashwin Vasavada. I work at the Jet Propulsion Laboratory in Pasadena, California, in the U.S. But I'll, kind of like to think I work on Mars really with this amazing rover. I look through its eyes and I explore Mars through its wheels and its driving around. So it's, as Jesse said, it seems like the best job in the world. But let's talk about Mars. So if you don't know a lot about Mars, it's the next planet out from the sun after Earth. And this is about the size of Mars. It's about half the diameter of Earth. But they're, of course, not as close together as what's shown here. Mars is about, if you take like half the distance between the Earth and the sun, and you add that to where Earth is, so another half the distance, that's how far Mars is from the sun. One thing you'll notice about Earth, that, one thing that makes Earth the most special planet in our solar system is the beautiful blue color with our oceans covering most of the planet. And Mars is red. It's famously the red planet. It's actually kind of more of an orange, but we'll call it red. And it doesn't have any blue, doesn't have any oceans like Earth does, but it does have a little water. And you can already tell that it has some water just because there's clouds over it. So it has a thin atmosphere, much less thick than Earth's atmosphere that allows us all to breathe and allows all that water to be there. But it's thin and it has some water in it, enough to form clouds next to the big mountains. But even though Mars is small and it has no oceans today, we consider it one of the best places to look for life outside of Earth. If we're going to look anywhere in the solar system for life that formed other than the life on Earth, we'd like to look at Mars. And you might think, why would we do that if there's no water today? Well, in the distant past, there may have been water. So I want you to look at Mars right here, and we're going to go back 3 or 4 billion years in time when I press this button. So that's what Mars might have looked like 3 or 4 billion years ago, when an ocean of water existed and the atmosphere was much thicker, the planet was much warmer, there were these big storms everywhere, there was probably raining and snowing, and all that made Mars a much more friendly place for life, if life ever existed. Right now, we don't know of anywhere else in the universe that has life except for Earth. So even finding that life exists on the planet right next to us would be one of the most important discoveries that humans would ever make. So that's why we're looking. And we like to look at Mars because it might have been a habitable planet at one time. So part of what curiosity is looking for is, was there ever life on Mars? So we want to ask whether Mars was ever habitable. And habitable just means, could Mars ever have supported life? If life, even if life never existed, were the conditions ever right to support life? So what makes a place habitable? Well, to answer that, you can think, what about Earth allows us to live? Now, one thing, of course, we all need is water. So, no matter if there's life on Earth, on Mars, on Europa, a moon of Jupiter, or anywhere else in the universe, we think life requires water. So we're going to try to figure out if a place is habitable. We look for signs of water. This picture that you're looking at now is actually a picture of Earth. It's a desert on Earth, but there's some snow and there's a little water that might have just rained a couple days ago or something. But otherwise, it's not probably one of our favorite places to live. But on the other hand, there is life all over this. You could dig in the ground, you'll find life. There's life crawling on the surface, there's plants. So even though this is kind of a harsh place on Earth, it has liquid water and it has the other ingredients that make it a habitable place too. What would those be? Well, another thing is carbon and other building blocks of life. So that's another thing we can look for on Mars to figure out if it ever was habitable. If we find that there was water at one point, maybe 3 billion years ago, and then along with that water, there was carbon so that life could assemble in the cells and the proteins and the nutrients and all those things that life requires using carbon and other elements like hydrogen and oxygen and nitrogen and sulfur. These are all the things that make up our cells in our body. So anywhere that else in the universe or on Mars, if life were to exist, it would need those same chemical building blocks. And then finally, life needs energy to survive, to multiply, to grow, all those things. So, you and I, we need water, we need carbon that makes up our bodies, and we need food. And that's the same thing even for a little microorganism that might have once evolved on Mars. So that's what Curiosity is looking for. Here's our JPL Rover family portrait. So the place where I work, we've sent several robots to Mars before. We started in 1996 with this small one. You could kind of hold it in your hand. It drove around about 80 feet in a big circle around the mothership it landed next to. But it was a huge achievement for us because it was the first time we ever drove a car on another planet. And then Spirit and Opportunity. These are a twin set of rovers. There was 2 of them that landed in 2003 or launched 2003, I think landed in 2004. And so these are golf cart sized rovers. They had solar panels. They were maybe, about the size of a golf cart, and drove around for a number of years. I think one, they lasted about a decade each, which is pretty amazing. But it was time to step up our game and send a giant robot to Mars. And in 2011, we sent Curiosity, the one I'm telling you about today, which, as I mentioned, is so big because it has the laboratories built in the front of it, and it has the 7-foot robotic arm that had to carry a drill that could jackhammer into rocks. It's hard to drill into a rock. So you have to have a big, powerful drill that kind of pounds the rock and then extracts that powder and then delivers that rock powder to the laboratories on board. You'll also see that there's no solar panels. So this rover has a different way of powering itself, and that is from nuclear energy. So in the back of the rover, in this part, there's actually 5 kilograms or about 10 pounds of plutonium. Now, plutonium is a radioactive material, and it's hot, and so it gives off heat for years and years and years, and we can turn that heat into electricity and power this rover. So the nice thing about not having solar panels is Mars is really dusty. So if you have solar panels like Spirit and Opportunity, eventually, and even Sojourner, this is a solar panel, the solar panels eventually get dusty and you can't generate electricity anymore. But with Curiosity and its nuclear power source, we can live for a long time. And I mentioned Perseverance, which is our latest rover from JPL, which is a very similar looking rover to Curiosity. It was built basically on the same blueprints, but then they do some different things, including collect samples that we hope will one day come back to Earth. So you can see me here for scale, but just for fun, let's see. Can you see, Jesse, can they see me through the camera?
Yeah, I can bring you up easily.
Let's do that.
Let's do that.
So I just want to give you another sense of how big this rover is. And here is the wheel. This is like our full-sized wheel, and there's the same size wheels as that rover that I'm shown next to in the picture. So this is one of Curiosity's wheels. This is not a real thing, of course, but it was made out of plastic. But it shows you how giant it is.
It's amazing. I love it.
And go back to the slides.
Thanks, man.
So we also had to teach Curiosity how to drive and do everything else. And so, I didn't know about this before I started working at JPL, but these robots that we send out to other planets, they actually live for a long time on Earth before we send them out. We build them and then we test them, sometimes for multiple years. and make sure they work perfectly and they can survive all the conditions we expect them to encounter. So sometimes we put them in a chamber and heat them up, put them in another chamber and cool them down, and then we shake them a lot. We put them through their paces so that we know that when we send them to Mars or anywhere else, they'll survive. So this is the day when all these people were teaching the rover how to drive and testing it. And you can see that the outer wheels all steer, so it can actually spin in circles like a tank. And you can also see that all these people are wearing these gowns. And that's because one of the things we're doing is looking for carbon on Mars to understand if it's habitable. And the last thing we want to do is send this robot all the way to Mars, have it make a discovery of carbon, and then realize, oh, it's actually because someone's greasy fingerprint got on the rover or someone's hair fell in it. So all these people are being very careful so that none of our human carbon goes to Mars with this rover. Well, the other challenge we had when we were building this rover is, how do you land it on Mars? We have to land a 1-ton car-sized rover on Mars, which, like I mentioned, only has a very thin atmosphere. So it's a kind of a funny situation. The atmosphere on Mars is just thick enough that you'll still burn up if you go too fast when you're trying to land. Unlike the moon, which has no atmosphere, so no chance of burning up in the atmosphere. But on Earth and Mars, when you're landing something from space, you have to be very careful about not you have a heat shield and all these things that protect you from burning up. And then once you get in the atmosphere, even though it's thick enough to burn you up, it's not thick enough to slow you down much. So you have to have a massive parachute. So look at these people down here on the bottom. This is one of the biggest parachutes that NASA has ever built in order to slow Curiosity down as much as possible, while this 1-ton spacecraft is hurtling down towards the surface of Mars. But even with this giant parachute, it wasn't good enough. So we had to invent a rocket jetpack to really slow Curiosity down. After the parachute stops doing its thing, we kind of disconnect the parachute, and then this rocket jetpack carries the rover down to the surface and then lowers it down on these ropes while the rockets are firing to slow it down and gently put it down on its own wheels on the ground. So the robot uses its own wheels as kind of like landing gear. And this is an actual picture of the Perseverance rover being landed on Mars by that rocket jetpack. You can see the dust of the surface streaming away as the rockets are firing. And you can see these ropes that are lowering the rover down, and the wheels are just about to hit the Martian soil. So that's pretty cool. Well, the final thing for us, now that we designed a rover, we know what it's supposed to do. We've figured out how it's going to land. We had to pick a site on Mars to explore. And we're trying to understand if Mars ever was habitable. And we're trying to understand if it was habitable like 3 or 4 billion years ago. So we wanted to go to a place where there are rock layers that formed 3 or 4 billion years ago. Because just like on Earth, you can go to a mountain that's made out of layered rock, and the bottommost layers are the oldest ones. And then as you go up in the mountain, they get younger and younger. So if you go to the bottommost layer of a mountain, it could be quite old, and it could tell you about what Earth was like when that rock layer first formed. And so we found the tallest mountain on Mars we could find, basically, that was made out of layered rock, so that we could drive the rover from the bottom of the mountain all the way up the side of the mountain, and starting with the oldest parts of the mountain and going younger and younger and younger. So as the mission progressed over now 12 years, we were able to explore one part of Mars history after another, kind of like reading the history of Mars in a book, chapter by chapter. And one thing that's cool about this mountain, it's not just made out of the same layers over and over. The layers actually change. So some of these layers at the bottom have iron minerals in them. They're kind of reddish from the rusty color of iron. Other layers have clay minerals. Clay minerals are really interesting because they tend to form when there's a lot of water around. So maybe when this layer with clay in it formed on Mars, Mars had a lot of water. Maybe that's when the oceans were there, or maybe that's when it was raining. And then above, there's a lot of layers made out of sulfates. And maybe you've never heard of a sulfate, but it's kind of like a salt. And so, on Earth, if you go out to the desert and there's a lake and the lake dries up, it often leaves big salt deposits behind. And that's the same kind of thing that might be happening here. Is these layers formed at a time when Mars was drying out and the water was evaporating away and leaving salt behind. So we can land here and drive up the mountain and kind of go through all these different parts of Mars's history. Maybe when there was a lot of water and maybe when the water was going away. Well, we landed, and this is one of the first really amazing discoveries we had. We were driving along and we found this rock, and it kind of looks like someone busted up the sidewalk in front of your house, like when the tree roots come up from the sidewalk. But this was on Mars, and this was a layer of rock that was kind of a rock made out of a bunch of other rocks cemented together. And some of these rocks inside this other rock were falling out, and we could tell that they're all kind of round. And that was really neat because nature, you don't really find like smooth, rounded rocks unless something like a river was carrying those rocks and they're all kind of crashing against each other and becoming smooth. And so finding this pile of really smooth rocks told us that we were probably driving through an ancient riverbed on Mars. So how cool is that? We went to go study Mars and look for evidence of water, which is one of those things we need for habitability. And we found that we were actually driving through a place where once a river flowed for miles and miles across the Martian surface. Here's our drill. This is a little video of of a test. I'll show you that again. Testing the drill on Earth. We actually have, you see the wheels here, and this is the drill. We actually have a whole other rover that stayed on Earth. So we built a twin of Curiosity that lives at JPL so that we had one to play around with and test and try out new things and actually fix problems with the one on Mars, kind of diagnose what's going on with the one at JPL. And this is one of those tests that we did. So just kind of up the hill from my office, we have Curiosity's twin that stayed on Earth. And here's what it looks like to drill into a rock. We only drill about an inch or two down into the surface. And then some of this powder goes up into the drill and it's collected and delivered to the instruments. So far now, after 12 years, we've drilled 42 holes on Mars. And this is our gallery, our photo gallery of all our drill holes. I remember each one, they're all special. And some of them are bright red, like the color of Mars, meaning that not only is the surface of Mars kind of rusty red, but even inside these rocks, it's rusty too. But others aren't. And that was really interesting for us to find that some of these, the surface is all rusty red, but when you drill into the rock, it's gray. And that's actually good for one day maybe finding evidence of past life, because this rusty process, which we call oxidation, can destroy evidence of ancient life if it's there for us to find. So if any microbes lived here, they might be destroyed if the rock gets rusted all the way through. But if it's kind of more fresh inside still, we have a better chance of finding evidence of life or even just evidence of carbon. And it turns out, in some of these drill holes, we found evidence of clay minerals, those minerals that form when there's a lot of water around. We found the salty minerals of those higher layers when Mars was turning into a drier planet. And we found evidence of carbon. We found that some of these drill holes that formed in places where there were once lakes on Mars actually had a lot of carbon and other elements that are needed by life in those lakes. So all that together told us that Mars really was a pretty fantastic place for life if it ever formed, because it had lakes of water. And in those lakes, there was carbon and there were nutrients and there were sources of energy, everything that would be needed for life to exist. And so, Curiosity has determined has figured out that Mars was once habitable. And now Perseverance, that other rover that's built very similar to Curiosity, is following up and going to return rocks from Mars back to Earth so we can figure out if life actually ever took hold. Well, this is what Mars may have looked like about 3 billion years ago. This is actually on Earth in South America. But, I think our best guess of what Mars may have looked like based on everything Curiosity's found is that it probably had these lakes, but the lakes were probably had some salt around them. And otherwise, it wasn't like super, it wasn't like totally tropical. It was actually probably always pretty dry like this. But even on a place like this on Earth, there's life everywhere. And so life can definitely survive in a place like this. Well, we kept exploring and found that sometimes the lakes dried up. And what you're looking at here are actually a bunch of mud cracks. Now, these are ancient mud cracks, so they're all turned into stone for now. But what we think happened here is that there was a lake and there was mud at the bottom of that lake. And then for some reason, maybe it was a hot day or maybe the climate was changing and that lake started shrinking. And some of the shore of that lake where the mud was got exposed to the sun, got heated up, and the mud just cracked, kind of like it does when puddles dry up on Earth. And those cracks were just kind of buried and then left for us to find like 3 billion years later. Kind of blows my mind because these cracks probably just formed in like 1 or 2 days on Mars. So what you're looking at here, 3 billion years later, is just something that happened in one particular day on Mars. But the last thing I'm going to tell you about today is one of our most recent, really interesting discoveries. We were driving around, here's our wheel, here's our arm with the drill on it. And we came across this amazing scene with all these bright white rocks. Now, most of Mars kind of looks more like what's in the background here. There's these dark rocks, there's these other lighter rocks, there's a lot of dark sand and dust, but everything's kind of orange or brown or red. Like pretty much everything on Mars is orange and brown and red. So when you come across this big field of bright white rocks, we're like, what's going on? We've never seen that. We have no idea what that is. These rocks are unlike anything we've ever seen on Mars or any rover or robot, has ever seen. So of course, we had to go drive over and check it out. And we went up to these rocks, and this is what they look like close up. And they're, I don't know, they kind of look like your teeth or something. They're very white, but they have a lot of holes in them. These are also probably 3 billion years old, so they've been kind of ground down by the sand and everything. And then, as we were driving over to check one of these out, we realized we actually had driven over a couple with our wheels and broken them open. And if the white rocks themselves didn't blow our minds, this really blew our minds. Inside these white rocks, we found all this kind of yellowish, greenish crystalline material, basically crystals. And when we figured out what the material was, it was pure sulfur. So sulfur is just a kind of chemical element like carbon, but this means that this particular rock had nothing else in it except for pure sulfur, and the sulfur had formed these crystals, and sulfur crystals are usually yellow or yellow green, and that's what we found. And it's really was amazing because pure sulfur crystals don't really form that commonly on Earth. They mostly form if you're near like a volcano that's going off and all the sulfur is coming out of it, or like a hot spring, like in Yellowstone National Park with all the geysers and hot springs. Maybe you'll get some crystalline sulfur like this. But where Curiosity was driving, we really didn't expect that there was any volcano even 3 billion years ago or a hot spring. So we were scratching our heads. And, even us scientists who know a lot about Mars and have all this experience studying it, sometimes we discover things we have no idea what's going on. And so now all of the people on our team across the world are trying to figure out how this crystalline sulfur material got formed on Mars. So this is a great thing for us to have a discovery that we can't explain, because it causes us to, really think hard and figure out something new about Mars that no one's ever discovered before. So with that, we're going to look back at this gorgeous picture of where we came from with the rover, and then we're going to look ahead to what's coming next. So there's so much for us still to discover. And with that, I think I'm done and love to take your questions.
Well, first and foremost, thank you so much for a tour of the most cutting-edge science on Mars and that gorgeous view to wrap up. My goodness. I mean, some of us hopefully are lucky enough to be familiar with views like this on Earth, but to be able to do that from another world, the fact that anytime you want, all of you kids can go on to the Mars Curiosity or Science Lab website and check out the latest images from another planet with a robot we sent there is like magic. I mean, that was not something I could do when I was a kid. You guys are so lucky. So thank you so much, Ashwin. And we're going to dive in with a big Q&A soon with all our classes, but I want to start with a little Kahoot. So for those who are new to Kahoot, the faster you answer, the more points you get, and what you win is Ashwin and I's everlasting respect. So who is paying attention to some of the things? I'll bring this up. We're going to dive in just a second, and then Mr. Barron's class, our Winnipeg crew, we're going to go to you guys first for questions. So put your thinking caps on, and we might end up going a little long today just because we're rebels and there's so many of you, but I'll try and keep it right on 45 minutes. All right. Let's get into this and dive in. I still... I've seen so many Mars presentations. I've seen Mars presentations from you before, and I still can't get over it every time we get the chance to feature this. So thank you again for all of us. All right. Question one. And Ashwin, if you want to help us with any of the questions with like 5 seconds to spare in each one, you can give us little hints if you'd like. Just saying. Okay. Question one. How big is Mars compared to the Earth? Who was listening at the beginning? We've covered a lot of ground, literally and figuratively. Is it a quarter the size? Is it half the size? Twice the size, or 4 times the size? Is Mars bigger or smaller than Earth? So many answers in
it. Good question.
I think so. I think last time we did this, a lot of people got this right. So yes, it's half the size of Earth. Way to go, guys. It's a lot smaller, but we also have a lot of ocean. So it's a similar amount of land surface to sort of navigate and go across, which is kind of an interesting little tidbit about it. But lovely sea lion has our lead going into question 2. So we come on to, let's see, how many rovers have been to Mars? We had a little family portrait there. We showcase some rovers. Has it only been 1 rover? Is it just Curiosity there alone all time? Is it 5? Is it 20 rovers? Or is it like 100 plus? There's just rovers everywhere. That's the dream. I think we want to get to 100
That is
plus
the dream.
Yeah.
I vote for 100 plus.
So 1700, yes, 5 rovers have been to Mars, which is just, still unreal. The fact that I've been around for most of them is amazing. And the fact that they are, a 20-year project, like it's so much to conceive of, to send these, to get them there. Space missions are a career, and that's what makes them so exciting, is you get to follow along and be part of this grand and epic story. All right. It takes 3 days to get to the moon. This question is the one that most people get wrong ever. I love doing this when we talk about Mars. 3 days to get to the moon. Is it 7 days to get to Mars, 7 weeks to get to Mars, 7 months, or 7 years? What do we think? I'll tell you this. It's not just around the corner. That's why Mars is so challenging. The moon is like right there. We can almost reach out and touch it. But most of you got this. Yeah, so 7 months. It's several months. There's like a window of time that it takes. But when we send something to Mars, it's a big journey. And we've got some Europa Clipper scientists coming on later this month. And that's going to take 6 years to get to Jupiter. Like, this space is huge. It's ridiculously huge. It's hard to fathom how big it is. All right. We got Carignac in our lead. Now, this one is not worth points. I just really wanted to see optimism versus pessimism. We will one day walk on Mars. Absolutely or no way? This fellow might not be really on Mars in this picture. We haven't gone to Mars yet, but I wanted to see what your thoughts are. I will note that overarchingly, when we have people on, the general consensus is the age of kids in these classrooms, like you guys are the ones that will be going to walk on Mars, which is crazy. And so most of you, 90% basically, thought that yes, we will walk on Mars. That's awesome. I certainly hope so. All signs point to that happening. We're going back to the moon in the next couple of years, which is wild. It's like the golden age of space exploration right now. Focus Macaw second, and first for all the marbles before we go to Mr. Barron's class is Karen Yak. Folks, let us know who you are. Thanks for playing along, everybody. We're going to head to Winnipeg. Mr. Barron's class, just an audio spot today, so we're just going to hear you guys. But if you want to unmute your microphone and come on in, we'll go to Mr. Bridie's class right after that, and we're going to come to everybody. So there's so many of you. Hello, Mr. Barron's class.
Hi, I'm Avika.
Hi.
Hi.
My question is, in the future, are you planning to send any more rovers to Mars?
Ooh.
Yeah. We'd like to send at least 2 more. We have one that's actually being built in Europe that has some pretty advanced ways of looking for life on Mars that we hope to send pretty soon. That one's called Rosalind Franklin, kind of has a long name after somebody famous. And then we have another robot that we might send to go pick up the samples that Perseverance, the big rover like Curiosity, is collecting right now. So those samples we want to bring back to Earth one day, and it might require sending another rover to go collect them and then put them in another spacecraft that comes back to Mars. So yeah, we have at least 2 and maybe even more. But I'll also just throw in one thing we didn't talk about, but some of you probably know about, is that Perseverance actually brought a helicopter with it too. So now we're going even beyond rovers. You know, we have not only driving things, but flying things on Mars.
It's insane. It's so much fun. Mr. Bridie's class, we're going to head to you guys, Georgetown. If you want to share a question on behalf of your class, you are good to go. And Miss Frapp, we're coming to you next. Hey, Mr. Bridie.
Hi. I just, one of the kids was asking, how do you know what happened to the water? Do you know the reason why the water left or is not on Mars anymore?
Yeah, great question.
Yeah, we think the water left because the atmosphere left. And so once the thicker atmosphere shrunk down, then the atmosphere is too thin to allow water to exist as a liquid, and it kind of either boils off or it freezes because it's so cold. So there's actually a ton of water, more than a ton, a whole bunch of water at the polar caps of Mars. So the water itself is probably mostly still there, but the atmosphere is what was lost. So water can't be liquid anymore. And the atmosphere was lost partly because the sun over time has kind of stripped the atmosphere away. And fortunately, that's not happening on Earth because Earth is protected by a big magnetic field. And Mars doesn't have a big magnetic field to protect it. So the sun, the solar wind can kind of strip off the atmosphere.
I'm so glad we got this question, because Venus and Mars are our closest neighbors in the solar system, and people really consider them sort of, you can see where Earth could go if things went wrong in either direction, sort of frozen Earth like Mars, boiling Earth where the atmosphere greenhouse effect goes runaway. It's been a source of some of the coolest science discoveries of all time, is studying the atmospheres of Mars and Venus, how they've changed over time, what they might have been like. So that's a very cool question. Thanks, Mr. Bridie. Ms. Pratt, we're coming to you, and then Mr. DeLeon, we're coming to you right next. We're going to get to everybody, so stick around, everyone. 5-6 in Ottawa. Come on in, guys.
Sorry, stand in front. Go. Why are we trying to find life in Mars?
Yes, why?
Yeah. I think the main reason is because we don't know if we're the only life in the entire universe. Wouldn't that be kind of amazingly scary in a way if we were the only thing out there? And also, you know, we know of a lot of planets around other stars. We know that there's billions of galaxies and billions of stars in every galaxy, and there's got to be other places like Earth out there somewhere. And if life was able to evolve on Earth, it was able to evolve somewhere else. So part of it is just sort of understanding what it means to be alive and how often that occurred throughout the universe. And yet we know nothing besides Earth right now. And so even finding life just next door on Mars would be incredibly important for us just as humans.
I think it's the greatest scientific question of all time. Like personally, and I'm a biologist by background, just the idea that there could be life elsewhere. And I would say pretty much universally, when we have people ask, do you think there is life elsewhere in the universe is so big. Almost every scientist we bring on says like almost certainly yes. But it would be so amazing to find it, whether it's intelligent life and we hear a radio signal, whether it's micro life, bacteria, something like that we'd find on Mars, Europa, or what else. It's such a profound question of our place in the universe, and it's worth exploring just for that. So I'm so glad we got that question. Thanks, Miss Fratt. Mr. DeLeon's class, let's head to Carson, California. Come on in, guys, and take us away. Hey.
Hello. How did you know how to build the first rover without knowledge about Mars?
Amazing.
Yeah, good question. So we had to sort of piece it together from a lot of different things. So we know we already had sent spacecraft to orbit Mars, like satellites. And so they took a lot of pictures of Mars and other measurements that we figured out that Mars had a thin atmosphere. It had rocks on the surface. It had sand. It had dust. We could figure out how steep the terrain was. Was it really slippery sand, or was there some rocks around that we could drive on? So we had some hints. And in a lot of ways, the surface of Mars isn't that different from like the surface of Earth. There's some ways that Mars and Earth are very much alike. It's kind of like a desert on Earth. So we could build a robot that could drive safely around like a desert on Earth without getting stuck in the sand, or without kind of, that's why it has 6 big wheels. It's not a four-wheel drive vehicle. It's a 6-wheel drive vehicle. So we can really make it through those kind of sandy and rough parts. Let's see. So yeah, that's kind of how we knew how to design it. We also had to account for the fact that Mars only has 1/3 of the gravity of Earth. And so part of the reason the wheels are so big is just to get that traction when a 1-ton rover actually doesn't weigh a ton. It only weighs 1/3 of a ton. So it can actually slip around more than a 1-ton car can on Earth.
Yeah, I love this. And I love the fact that we just keep learning and making them better and better. I mean, as we've sent more rovers to Mars, we learned some of the things that have stopped the other rovers in their tracks. And one of the things is just making the rover much bigger. We see this with Curiosity. You saw that family portrait. I mean, the bigger, heavier vehicle can get over more different kinds of terrain than something that's a lot smaller. So it required that crazy sky crane, which is still one of the most insane things ever engineered in human history, to accommodate getting that to the surface. But it was so worth it because we've got these robust, epic vehicles that can do even more science and even more exploration. So very cool question, guys. All right, we've got time for 4 more questions. I'm going to take a quick run from YouTube and then the order I put in the chat. Miss Peck's class, welcome in, guys. So nice to have you at Stephen Central. They want to know, is there garbage on Mars left by us? Are we polluting another planet as well as our own?
Yeah, that's a good question. And actually one that NASA thinks about. We're trying to discover if there is ever life on Mars, or maybe even if there's still life today. So one of the types of garbage we really don't want to bring to Mars right now is anything living. So we actually clean these spacecraft really well. We try to make sure like all the bacteria, all the microbes, everything else that might be on the spacecraft at Earth is taken off, so that when we land these spacecraft on Mars, they're really clean and they aren't going to spread viruses and life on Mars that, when we're trying to actually figure out if life ever occurred on its own. But we do kind of bring some garbage in the sense that the parachute that landed Curiosity is now just laying on the surface somewhere. That robot jetpack went out and crashed after it did its job landing Curiosity. But we try to kind of limit the amount of garbage, but some of it is needed. But we certainly don't pollute when we can avoid it.
Yep. I was going to say, no one does a better job of trying to make sure they don't have an impact than NASA. And that sterilization bit is really big. It would suck if we went there and we're like, wow, we found life. And it turned out it was a bacteria that we brought there on the spacecraft. So they're very diligent about making sure that doesn't happen. And so I'm really glad we got that question. Thanks, guys. All right, 3 more live. I'm sorry we're going a little long, but I think it's worth it. And there's so many of you. I wanted to take all your questions. So Viola Desmond, we're coming to you. Mr. V, and then Avoca West. We're going to wrap up with you right at the end. Come on in Milton, guys. Hey. Hi.
We're 6'3". Okay.
I have a question.
How long away are we from going to Mars if it is safe, and how many people could live there?
Ooh. Yeah. Well, how long away? Well, we're working on it, and it's really challenging to land 1-ton rovers, and it's just way, way more challenging to safely land people and allow them to live for a long time. So we hope that maybe, in the next 10 to 20 years, speaking optimistically, we can think about sending people maybe for a short trip. But eventually, we would like to send people to live there for a long time, kind of like people live in the South Pole on Earth. They live under the ocean now for some extended periods of time in some places. So, explorers and scientists probably will be the first people to go, and maybe go for a few weeks at first, and then maybe some months, and then maybe a permanent base on Mars in the next, few decades.
I would say we've actually featured people live from the South Pole and live from bases in the bottom of the ocean before that are
Nice.
sort of prepping and seeing how people can survive things like that in these extreme environments. So fingers crossed for us. All signs point to some really cool stuff in the next few decades. So thank you for that, guys. Mr. Viesklaus, Burkvale, come on in and take us away. Hey. Hey.
How old were you when you decided to work for NASA?
Great question. Thank you so much.
Fantastic. I think I was right about the age of a lot of you. I think I was like in fourth, fifth, sixth grade, somewhere around there. And actually I was reading like a book that had pictures from the very first spacecraft that NASA ever landed on Mars. And I was kind of blown away because it was a picture from a robotic spacecraft that landed in 1976. And it was looking out over Mars, and there was this rocky surface and a desert that just went on for miles and miles. And I couldn't believe that there was another place outside of Earth that you could just kind of walk out on, kick some rocks around, climb up a mountain. It was a whole other world besides Earth, and I wanted to go explore it.
Ashwin, what a beautiful answer. And I think it's something that when I was a kid, planets abstract, they're out there, but they're all worlds, moons, planets. They're all places that we could theoretically go and explore and live and all these other things. And it's magical to think that our own solar system has dozens, hundreds of these, from things like Ceres and Eris and all the way up to Jupiter and these gas giants that dwarf the Earth. I mean, it's just such a special solar system that we find ourselves in, and we're even discovering more planets and moons around the galaxy and beyond. So what a cool story. Thank you so much for that. If you know the book name, do you know the book name offhand?
No, I don't.
Okay. I mean, the good news is that kids can literally go to the website. I'm going to pass this along to all our teachers, but go here, see Mars as a place when you're done this, and hopefully be inspired yourselves. It's a pretty special opportunity for classrooms these days. Guys, time flies when you're having fun. I'm going to go to Avoca West, our Glenview, Illinois crew, to wrap us up with one final question, and then I'll bring you all in to say thank you and farewell. Come on in, grade 3s, and take us away.
How old is Mars?
Ooh, how old?
So really old, as old as our solar system. So the universe, everything out there is, I don't know what the latest is, 12 or 13 billion years old. So relative to the universe, it's not that old, but our solar system formed maybe about 4.5 billion years ago. And then Mars formed as part of that process. So it's also about 4.5 billion years old. Yep. And then this crater that we're exploring, when it had all the lakes and everything in it, that was about 3 billion years ago. So it's all, a long time ago. But compared to the whole age of the universe, it's actually kind of recent.
But very old from a human perspective. And I mean, this is what's so cool too. And the fact that we have the scientific tools to be like Mars and the Earth are 4.5 billion years old. The universe is 13 plus billion years old. It's the joy of this as a field in general, is that we have the tools and ability to even understand things like that about the world beyond us and the universe beyond us. So what a perfect question to end on. Ashwin, before we bring in the kids to say thank you and farewell, is there any last message you want to share about curiosity, about Mars, anything to leave us with today?
I just hope you all follow along and are excited about learning about Mars or the other planets. And as Jesse said earlier, I'm kind of jealous because you're probably the generation that's actually going to put footsteps on Mars. I get to send robots, which is awesome, but you might actually get to go there.
Hard to beat that for a final message. Kids, keep doing science, keep doing math, get involved, learn more, volunteer. All these things will put you on a path to ending up like Ashwin, like people that get to go to explore the moon, Mars, and beyond. So really appreciate you tuning in today. Ashwin, if you want to stick around for the end of the broadcast so you and I can chat for a minute, but for now, we're going to bring in all our classrooms to say a big thank you and farewell. Miss Fratt, Mr. Bridie's class, Mr. DeLeon's class, Mr. V of Oka West, thank you so much, everybody. Bye for now, everyone.